Hello students, welcome to YourPedia platform. I am Rohit Singh, your civil mentor. Today I'll be taking a question from the NPTEL assignment booklet of civil engineering from the topic environmental engineering which is given on page number 141 as question number 24 of this booklet, right? So in this question they have given you that there is a grid chamber of length 7.5 meter and depth is 0.9 meter, and they have also given you that the velocity of flow is 0.3 meter per second, right? So, and they have provided you acceleration due to gravity values, dynamic viscosity values along with gamma of water, right? So before discussing about this question, let me show you a diagram showing a grid chamber in STP. So this is a grid chamber in STP. Basically what happens is water enters through inlet, and our main aim in this grid chamber is to remove particles before leaving the grid chamber. So what happens is the particle while traveling through the grid chamber settles at the bottom of the tank. The lighter particles will settle later on and the heavier particles settle in the start, right? And then the particles are removed from this tank. So ultimately the water will be free of particles, right? So now let us come back to our question, right? So here in this question they have given you the velocity of flow as 0.3 meter per second, specific gravity of solids is 2.5, acceleration due to gravity is 9.8 meter per second and meter square per second, and dynamic viscosity of particle of the fluid and dynamic viscosity of fluid is 1.002 into 10 to the power minus 3 Newton second per meter square at 20 degrees C, and gamma of water or the unit weight of water is given as 1000 kg per meter cube, right? So let us first convert it into Newton per meter cube, right? So it will be 10 into 10 to the power 3 Newton per meter cube, right? So what happens is, what we'll do is basically the main aim of our experiment or this grid chamber is to remove the particles before leaving the tank, right? So all we want is when the particle travels through this grid chamber, let it takes t amount of time in traveling horizontally, then in the same time t the particle should travel this much of distance, which is d, so that or more, because if the particle settles before leaving the tank then it can be easily removed. So for that, and they are asking you to find it for 100% efficiency, what will be the diameter of the particle which can be removed, right? So let us start our question like this. Okay, so let the diameter of particle be dmm, right? And now they are asking you to find the diameter of particle d with 100% efficiency removal, right? So in order to find 100% efficiency, we all know that the time taken by particle, so here let us come back to our diagram. So the time taken by particle to reach the bottom of the tank horizontally should be equal to the time taken by the particle to reach the bottom vertically, right, in this direction. And we know that in the direction of the flow the velocity is given as velocity of flow, which is already given in the question, right? And in the vertically downward direction the velocity will be settling velocity of particle, right? So let's start our question like this. So time taken by the particle will be equal in horizontal and vertical directions, and we know that time is distance upon speed, right? So the horizontal distance is L, and so the horizontal distance is L, and the time taken by the particle or the velocity in the horizontal direction is Vf, right? Similarly, the time taken by the particle in the vertical direction will be equal to the depth of the tank upon the velocity of particle in the downward direction, which is settling velocity, right? So we can easily relate from this that L upon Vf should be equal to d upon Vs, right? Time should be equal, and where Vs is the settling velocity of particle of diameter dmm, right? So now in this relation we already know the value of length, the value of depth, as well as the value of flow in the horizontal direction. All we need to calculate is the velocity of settling velocity of particle in the downward direction. Now as there was a scientist as Stokes, so basically there is a Stokes law which is valid for particles of diameter in between 0.002 mm to 0.2 mm, right? So this Stokes law is valid in this range, and it says that the settling velocity of particle will be equal to gs minus 1 gamma w d square upon 18 mu, where gamma w is unit weight of water, d is diameter of particle, and mu is dynamic viscosity of fluid, right? So let us substitute the values in the above equation in order to find the solution for the velocity of flow. So settling velocity. So the settling velocity will be equal to gs minus 1, where gs is 2.5, all right, 2.5 minus 1, and gamma w is already given in the question as, gamma w is given as 10 into 10 raised to power 3 Newton per meter cube, right? So let us substitute the value of gamma w. So this will be 10 into 10 raised to power 3 Newton per meter cube. And d, we have already assumed that the diameter of particle let be dmm. So let us convert the diameter of particle from mm to meters. So d into 10 raised to power 3 will be in meters, and this is whole square, right, divided by 18 mu, where mu is the dynamic viscosity of particle, and it is given in the question as 1.002 into 10 raised to power minus, so it is given as 1.002 into 10 raised to power minus 3 Newton second per meter square, right? Right. So we have all the values. So from this we can conclude that the settling velocity will be equal to 0.8136 times d square. Now we have also find out the settling velocity of particle. All we need is to put these values back in the relation of the time taken by the particle to reach the bottom horizontally and vertically, and let us equate these values, and we can easily find the largest diameter of particle which can settle in the tank with 100% efficiency, right? So all we need to do is substitute in this formula, right, in this relation. So L is 9.5, so let us substitute the values. So L will be 9.5, right, divided by Vf. Vf is velocity of flow in the horizontal direction, which is already given in the question as 0.3 meter per second, right? This is meter and this is meter per second, and this shall be equal to depth. Depth is given in the question as 0.9 meter, and upon Vs, and Vs basically Vs, and Vs is 0.8136 d square. All right. Now we have our equation or a relation between d, and we can easily find the value of d. So from this equation on solving, you will get the value of d as 0.21 mm, and this is the final answer of this question as asked in the question. So now let us come back to our options. So basically there are 4 options. A is 0.04 mm, so basically A is not the correct answer. B is 0.21 mm, yes, so the B is correct option. So let us mark the option B as the correct option, right? So this is the correct option, right? Let us also check the answer which is given on the page of 154 of this booklet. So the answer to the question number 24 is given as B option, which is 0.21 mm. So like in this way we can easily calculate or solve different problems regarding environmental engineering. I hope you understood. Have a great day. Keep preparing. Thank you.